So it talks about composition over inheritance. So inheritance, we know it's like my subclasses are going to inherit the features from it superclasses, and composition is like rather than depending to inherit the features from the superclasses, my each class will have an option to include those features by itself and not depend on the superclass. And then it talks about separate classes for different features, and it says let concrete classes decide their own features rather than inheriting all the features from the superclass. Okay, we are going to see all these principles, how it helps us with some code and a scenario, which is we have to design a gaming fight application with different players, and each fighter player has a different set of moves. Okay, so let's try to go to some code and see. So suppose if I'm not using the strategy design pattern, and if I have to design such an application, how I'm going to do that? So first of all, what I will do is I'm going to create a abstract class called fighter player, which will have different abstract methods, and each abstract method refers to an action or a move, right? Run, jump, straight punch, and so on. And now what I'm doing here is I'm defining a rule in a way that all my concrete implementations of fighter player will have to override these actions. Okay, so fine, I create this abstract class. Okay, and now I start coding for its concrete implementation. So I go to fighter player 1, I start coding fighter player 1 class, and I extend this fighter player abstract class, and then I'll have to override all the methods. Fine, so suppose my fighter player 1 is capable of performing all these actions, no problems for me. I will just override these methods and I will provide an implementation specific to fighter player 1. Fine, up till now. Now what's going to happen is tomorrow I start coding for fighter player 2 implementation, and I find in the requirement that my fighter player 2 should not perform these actions, leg sweep and disappear. It should be incapable of performing these two actions. Now when I code this, what I'll have to do, when I'm going to provide a concrete implementation for this leg sweep abstract method, I'll have to provide a dummy implementation, leg sweep action not available, and similarly I'll have to do it for disappear method, right? So by now a thing will come to my mind that I'm writing some extra code, and suppose if I create n number of such concrete classes for fighter player, then I will end up writing a lot of code which is irrelevant, which is not required, and I'll have to keep on providing the dummy implementations, right? So it's a bad design. It's not good because I'm writing extra code. So but fine, I go with this approach, and after just creating these two classes, fighter player 1 and fighter player 2, I try to test it out. I try to test it, suppose with a client app or something. For now I've just made a game app test, and when I'm going to test it, suppose if I first test fighter player 1 and I call this disappear method. Perfect, fighter player 1 disappear, because I have in the implementation I have provided this for fighter player 1. I try some other thing, leg sweep, and I do this. Perfect, leg sweep. I now try to test fighter player 2. I try to do the same thing, leg sweep. So you remember, my fighter player 2 as per requirement is not supposed to perform the leg sweep, but why am I getting the option to perform the leg sweep? That's the first point. Again, it's a bad design, right? I should not get the option to even call this leg sweep, but I am getting this option, and when I run this, leg sweep action not available. Dummy implementation which I provided here. Again, this is not right. So now I decide to go with strategy design pattern in order to overcome these shortcomings in my design. So how I'm going to do that? Let's see that. So first of all, what I'm going to do is I'm going to, let me close this out, create something like just give me a second, fighter player common actions. Okay, this is an abstract class, and I'm going to keep only the common methods here. Okay, which will be which has to be performed by all the fighter players, right? So as per the design, as per the requirement, I know, okay, run, jump, and swim has to be performed by all the fighter players. So I'm going to keep only these, I'm going to declare only these methods in my abstract class called fighter player common actions, right? Not all. Secondly, for other features, I'm going to have them as a separate feature or a component. So for that, I'm going to create a interface, special moves. I'm going to declare a method called action, and all my special features or special moves are going to implement this special move and provide the implementation under action method. So for leg sweep, for front kick, for open hand strike, and so forth, right? Again, I might come across a situation that all my special features should not be called a special move. Then I can define them separately also. I am going to create a different class which is solely responsible for performing a special type of action called disappear, and I'm going to provide its implementation, right? So now, up till now, I have covered the first 2 points of strategy design pattern which I talked about. The first point, that I'm not only relying on inheritance, right? I'm only relying on inheritance for a common set of features, and I'm having a different component for each different type of feature or a special move or a special action, right? Fine. So now when I'm going to provide a concrete implementation for my fighter players, so let's do it for one strategy fighter player 1. It will extend this abstract class having common features declared. I'm going to simply override it with the implementation specific to this fighter player, run, jump, and swim. And now I will let my this concrete implementation of fighter player decide what all features it requires and it should have. So that's the third principle of strategy design pattern. So how I'm going to let it decide is via constructor. I'm going to accept only those special features which it can perform. I'm doing it via constructor here. If you are using some Spring framework and all, you can auto wire these special features. Okay, because all these special features are now a separate component in itself, right? So yes, I'm going to do this, and I'm going to perform getters for this special moves. So you see this disappear action. I'm going to keep it here, and I'm going to provide a getter for it, and in the constructor I'll be mapping it with the real object of disappear action. Okay, so with this now if I try to test it out, what I will do is, again going back to game app test, let's see this out. Before testing it out, one more thing I would like to highlight. By now I have got rid of all the extra code. So my fighter player 1 is should not perform the leg sweep, so I'm not having any dummy implementation or any code which is related to leg sweep here. Okay, so no extra code. And now if I go here, what I have to simply do while creating an object of a strategy fighter player 1, I'm going to pass all the special actions to it, which are a different component. So I'll just pass it those objects to its constructor. It's gonna map it here, and it has an getter method to get those objects, those special features or components, right? So I'm going to do this, and now if I run this, run, which is a common feature, right? Fine. Fighter player 1 run at a speed of 15 kilometers per hour, which is here, coming from here. Okay, this run, it is overridden, which was present in my common abstract class. Okay, fair enough. Now if I have to perform leg sweep, this fighter player is as per requirement should not perform the leg sweep, but I will try it out. Leg sweep, I'm getting no option, right? So whatever is relevant action for this fighter player, I'll get only those options. Okay, leg sweep not available, perfect, no issues. What about disappear action? So you see I'm getting the object of get disappear action, which is coming from there. So I'll get this disappear action, which is this reference is right now pointing to this disappear action object, which I pass to its constructor, which is nothing but this. So when I'll call this disappear method, it should print this, right? So that's what I'm doing, calling this, and yes, it will print this disappear. Similarly for any other action, such as say what I passed, front kick here, right? So I'll get an object of front kick here, and on this I'll have to call action method, right? Because this front kick is overriding this action method, which is coming from this interface, right? So I'm going to call this move forward and front kick. Why? Because in this action method I am saying move forward and front kick, right? So you see that I have overcome the second problem also. I'm only getting those options or those actions to perform which are specific for this fighter player, not all. Okay, so this is other advantage. Similarly, suppose at the later course of time I want to change its implementation for front kick, move forward and front kick. I will remove this move forward and I say just front kick. Okay, so I'm changing the implementation for front kick. So now I'll have to just change at one place, and if I run this again, I'll just get front kick. If I was not using this strategy design pattern and I was not having each feature as a separate component, then what would have happened if I was just going with inheritance? See here, fighter player 1, front kick. I'll have to change the implementation here also. I have to make it only front kick. Then in fighter player 2 also I'll have to do the same thing. So change in one feature, but change of code across multiple classes, because I was just relying on inheritance. I was not having separate components for separate features, so I'll have to do that. Okay, so this is how strategy design pattern helps us. So in a more real world scenario, when you have to start designing an application, so make sure that you don't put all the features or all the methods declaration in a common abstract class or a kind of interface. Don't keep everything and don't make it a rule that all your concrete classes will have to override those, because your all concrete classes might not need all those things and they'll have to provide a dummy implementation. So only keep the common features in the superclass or interface. Okay, first thing. Then again, keep all the features as at a level of components, so that any change to that feature you have to just make the code change at one place. Okay, yeah, so this is how. So now you must have seen that inheritance is always not a better choice, though it helps us to define some rules. It helps us to kind of say and by looking at the interface or by looking at the any abstract class or super class, we can know that okay, all the concrete implementations are going to perform all these actions or features, but no, don't keep everything in the superclass. Okay, only keep the common things. Make sure by reading at the requirement you choose those common features and keep it at the level of the superclass. um, Fine, I think uh, try to think more on the theme of this design pattern. It is a very useful design pattern, I must say, and in a way you must be or will be implementing this whenever you are going to design any software application. I mean, few of the say design patterns by my experience are very important, and knowingly or unknowingly you use them, such as strategy design pattern, facade is one of them, factory design pattern, and all those things. So yeah, this was all about the strategy design pattern. I hope you must have got the theme of it. You must have got the scenarios where it helps and what it how it helps you to better design your software application. Thanks a lot, friends.